Section 1, the new battlefield, where machines take the lead. Warfare is changing. It's no longer just about soldiers and tanks. Battlefields are now home to advanced robots. These machines are not from science fiction, they are real and rapidly evolving. From unmanned aerial vehicles soaring in the sky to ground robots navigating treacherous terrain, the future of warfare is increasingly autonomous. This rise of military robots marks a significant shift in how wars are fought and won. The speed of this technological advancement is staggering. What seemed like a futuristic concept just a few decades ago is now a reality. Today, robots are not merely tools of war but are evolving into sophisticated machines capable of complex tasks. They can patrol borders, disarm explosives, and even engage in combat, all while keeping human soldiers out of harm's way. This evolution is not just about building bigger, stronger machines, it's about developing smarter, more adaptable robots that can react to dynamic situations. The driving force behind this rapid evolution is the integration of cutting-edge technologies. Artificial intelligence, machine learning, and advanced sensors are giving robots unparalleled capabilities. They can process information, analyze their surroundings, and make decisions with increasing autonomy. This means robots can learn from their experiences, adapt to changing environments, and operate with a level of independence never seen before. The implications for future warfare are profound, with robots poised to play an even more significant role in military operations worldwide. As we look to the future, the integration of robots and advanced technology will extend beyond Earth, with soldiers of the future preparing to land on new planets, equipped with the latest in military robotics. Section 2. From fiction to reality. Military robots on the march. The idea of robots fighting our wars has long been a staple of science fiction. From the Terminator to the droids of Star Wars, we've been fascinated by the potential and peril of autonomous war machines. But what was once confined to the realm of imagination is now a tangible reality. Military robots are no longer a futuristic fantasy, they are actively deployed in conflict zones across the globe. These robots come in all shapes and sizes, each designed for specific tasks and environments. Some are large and imposing, like unmanned ground vehicles capable of carrying heavy weaponry. Others are small and agile, designed for reconnaissance and infiltration behind enemy lines. Their capabilities vary too, from disarming improvised explosive devices to providing surveillance and intelligence gathering. As technology advances, these robots are becoming increasingly sophisticated, pushing the boundaries of what machines on the battlefield can achieve. The development and deployment of military robots are not limited to a single nation. Across the globe, countries are investing heavily in this technology, recognizing its potential to revolutionize warfare. The United States, China, Russia, Israel, and many others are all developing their own unique robotic platforms. This global race to build the most advanced military robots will undoubtedly shape the future of warfare for decades to come. Imagine a detachment of soldiers of the future preparing to land on a distant planet, equipped with the latest in robotic technology. Section 3. A closer look comparing global robo-warriors. The world of military robots is diverse, with each country tailoring its technology to specific needs and doctrines. The United States, a pioneer in military robotics, boasts a wide array of platforms, from the MQ-9 Reaper drone known for its precision strikes to the smaller PackBot designed for bomb disposal. These robots are characterized by their advanced sensors, high-resolution cameras, and sophisticated software, allowing for greater autonomy and effectiveness in various combat scenarios. China is rapidly catching up, investing heavily in its own robotic programs. Its platforms, like the Sharp Claw, a tracked vehicle designed for urban combat, and the Blowfish, an underwater drone for maritime surveillance, showcase China's ambition to lead in this field. These robots often prioritize agility and adaptability, reflecting China's focus on developing versatile platforms for diverse environments. Russia, known for its robust military hardware, is also making strides in robotics. Its Uran-9, an unmanned ground vehicle armed with cannons and anti-tank missiles, demonstrates Russia's focus on firepower and heavy weaponry in its robotic platforms. This focus on offensive capabilities reflects Russia's military doctrine and its approach to integrating robots into its existing forces. Section 4. Man's Best Friend. Upgraded, introducing military robot dogs. Among the diverse range of military robots, a particular category stands out: robot dogs. These four-legged machines, inspired by their canine counterparts, are capturing attention for their agility, versatility, and growing list of capabilities. Unlike their wheeled or tracked counterparts, robot dogs excel in navigating uneven terrain, making them ideal for reconnaissance, surveillance, and even combat support in challenging environments. These robotic canines are not just about mimicking the mobility of a dog, they are equipped with advanced technology that elevates them to valuable assets on the battlefield. High-resolution cameras, thermal imaging sensors, and even weapon mounts are just some of the features that make these robot dogs formidable tools for modern warfare. Their ability to go where other robots struggle to tread, coupled with their growing arsenal of capabilities, makes them a game-changer in military operations. Two prominent examples of these robotic canines are China's Unitry B2 and the USA's Thermonator. These robots, while sharing some similarities in design and purpose, also highlight the different technological approaches and strategic thinking behind their development. Understanding their capabilities and limitations provides valuable insights into the evolving landscape of robot warfare and its potential impact on future conflicts. Section 5, Unitry B2, China's Agile all-terrain hunter. China's Unitry B2 stands as a prime example of how robotics is transforming military capabilities. This four-legged machine, resembling a futuristic hound, is designed to navigate challenging environments, providing support and intelligence in various combat scenarios. Its agility and adaptability make it a valuable asset for reconnaissance, surveillance, and even logistics in difficult terrains. The B2 boasts impressive mobility thanks to its articulated legs and powerful motors. It can traverse uneven terrain, climb stairs, and even regain its footing after a fall, making it ideal for navigating the complexities of urban warfare or mountainous regions. This agility is coupled with a robust build, allowing the B2 to carry a significant payload, including sensors, cameras, and potentially even weapon systems. One of the key features of the B2 is its modular design. This allows for customization based on mission requirements. Need to scout ahead and provide real-time intelligence? Equip the B2 with high-resolution cameras and sensors. Need to transport supplies to troops in challenging locations? The B2 can be configured to carry and deliver essential gear. This adaptability makes the B2 a versatile tool for various military operations, showcasing China's focus on developing multi-purpose robotic platforms. Section 6, Thermonator, the USA's pack leader in robot warfare. On the other side of the world, the United States is developing its own impressive robot dog, the Thermonator. This robust machine, built by Ghost Robotics, is designed to operate in challenging environments, providing support and firepower to troops on the ground. Its name, a play on the Terminator franchise, hints at its potential as a formidable force on the battlefield. The Thermonator is built for endurance and versatility. It can operate for extended periods, traverse various terrains, and withstand harsh weather conditions. Its modular design allows for customization with a range of payloads, including sensors, cameras, and even weapon systems like rifles and grenade launchers. This adaptability makes the Thermonator suitable for various missions, from reconnaissance and surveillance to direct combat support. One of the key features of the Thermonator is its focus on semi-autonomous operation. While controlled by a human operator, the robot can perform certain tasks independently, such as following waypoints or identifying and engaging targets within set parameters. This level of autonomy allows the Thermonator to provide valuable support to troops while minimizing the cognitive load on human operators, highlighting the growing trend of human-machine collaboration in modern warfare. Section 7, Beyond the Battlefield. Robot dogs in civilian applications. The advancements in robotics, particularly in the development of robot dogs, aren't limited to military applications. These versatile machines are finding their way into civilian sectors, showcasing their potential to revolutionize various industries and aspects of our lives. Their agility, adaptability, and growing capabilities make them suitable for a surprising range of tasks beyond the battlefield. One prominent example is in search and rescue operations. Robot dogs can navigate rubble and debris in disaster-stricken areas, using their sensors to locate survivors and provide vital information to rescue teams. Their ability to access areas too dangerous or difficult for humans makes them invaluable assets in such situations, potentially saving lives and aiding in recovery efforts. Another promising application is in law enforcement. Robot dogs can assist police officers in various tasks, such as patrolling areas, investigating suspicious packages, or even apprehending suspects in high-risk situations. Their agility and speed, coupled with their ability to carry cameras and sensors, make them valuable tools for law enforcement agencies looking to enhance situational awareness and officer safety. Section 8. The changing face of warfare. How robots reshape combat. The increasing presence of robots on the battlefield is not merely a technological evolution. It signifies a fundamental shift in the very nature of warfare. These machines are not just tools, they are changing how wars are planned, fought, and ultimately won. Understanding these changes is crucial for adapting to the evolving landscape of conflict in the 21st century. One significant change is the potential for robots to reduce casualties. By taking on dangerous tasks, such as reconnaissance in hostile territory or disarming explosives, robots can minimize the risk to human soldiers. This shift towards unmanned systems allows military leaders to achieve objectives while minimizing the human cost of war, a driving force behind the increasing investment in robotic platforms. Robots also offer unparalleled precision and endurance. Unlike human soldiers, robots don't experience fatigue, fear, or hesitation. They can operate for extended periods, maintain focus on assigned tasks, and execute orders with precision, making them valuable assets in various combat scenarios. This precision and endurance can lead to more effective operations and potentially shorter conflicts, as robots can maintain a relentless pace that human soldiers cannot match. Section 9. The ethical tightrope. Navigating the moral minefield of robot warfare. The rise of military robots, while offering potential advantages, also presents profound ethical questions that society must grapple with. The idea of machines making life-or-death decisions on the battlefield raises concerns about accountability, proportionality, and the very nature of human judgment in warfare. These ethical considerations are complex and require careful examination as we venture further into the age of robot warfare. One of the most pressing concerns is the issue of accountability. If a robot malfunctions or makes a decision that results in civilian casualties, who is responsible? Is it the programmer, the manufacturer, or the military commander who deployed the robot? The lack of clear lines of accountability raises serious questions about potential war crimes and the legal framework governing the use of autonomous weapons systems. Another ethical concern is the potential for an arms race. As countries invest heavily in military robotics, there is a risk of an escalation in the development and deployment of increasingly sophisticated and potentially destabilizing autonomous weapons. This could lead to a future where wars are fought at machine speed, with less time for human intervention and a higher risk of unintended consequences. Section 10. Autonomous assassins, addressing fears of uncontrolled robots. The increasing autonomy of military robots often sparks fears of machines running amok, turning on their creators, or making decisions that escalate conflicts beyond human control. While these fears are understandable, often fueled by science fiction portrayals of rogue AI, it's essential to separate hype from reality when discussing the capabilities and limitations of current robotic technology. It's crucial to understand that today's military robots, even the most advanced ones, operate within predefined parameters set by human programmers and operators. They are not sentient beings capable of independent thought or malicious intent. Their actions are dictated by algorithms and code, making their behavior predictable and controllable within the bounds of their programming. However, this doesn't mean there are no risks associated with increasing autonomy. The potential for malfunctions, hacking, or unintended consequences remains a concern. That's why it's crucial to have robust safety protocols, fail-safe mechanisms, and clear lines of human oversight in place to prevent accidents and ensure that robots remain tools under human control. Section 11. The future of warfare. A glimpse into tomorrow's battlefields. Predicting the future of warfare is a complex endeavor, but one thing is certain: robots will play an increasingly prominent role. As technology advances, we can expect to see even more sophisticated, adaptable, and autonomous robots on the battlefield, changing the dynamics of conflict in ways we are only beginning to comprehend. One potential development is the rise of swarms of robots working in unison. Imagine hundreds or even thousands of small, interconnected drones coordinating attacks, overwhelming defenses, and adapting their tactics in real time. This concept, known as swarm intelligence, could revolutionize warfare, making it incredibly difficult for adversaries to defend against a coordinated attack from multiple directions, and with unpredictable movements. Another possibility is the development of robots with advanced cognitive abilities. Imagine robots that can not only follow orders but also learn from their experiences, adapt to changing situations, and even make tactical decisions independently. While this level of artificial intelligence is still in its infancy, it's not outside the realm of possibility, and its implications for the future of warfare are profound. Section 12. Collaboration, not competition, human-robot teams in action. The future of warfare is not about robots replacing humans entirely, it's about human-robot collaboration. The most effective fighting force will be one where humans and machines work together, leveraging each other's strengths to achieve mission objectives. This collaborative approach recognizes that humans and robots excel in different areas, and combining their capabilities can lead to a more formidable and adaptable force. Humans bring to the battlefield their strategic thinking, adaptability, and intuition, qualities that are difficult to replicate in machines. Robots, on the other hand, offer precision, endurance, and the ability to operate in hazardous environments without risking human lives. By combining these strengths, human-robot teams can achieve what neither could do alone. This collaboration will require training and adaptation on both sides. Soldiers will need to learn how to operate alongside robots, trust their capabilities, and understand their limitations. Similarly, robots will need to be designed with human-machine interaction in mind, ensuring seamless communication, intuitive interfaces, and a shared understanding of objectives and strategies.